Hi everyone, I'm Mrs. Hannah Ingelin. In this video, we will discuss about what is a statically determinate structure, how it can be determined for various types of structures. These are the equilibrium equations that can be used to find the unknowns at the support or the redundant forces at the support. So for a two-dimensional structure, we have these three equilibrium equations: summation of all the vertical forces, summation of all the horizontal forces, summation of all the moments is equated to 0. For a three-dimensional structure, if it is a steel structure, that is pin jointed structure, and for a three-dimensional rigid jointed structure, that is RCC structure, rigid jointed structure, we have these 6 equations of equilibrium. Summation of all the forces in these 3 directions is equal to 0, and the moments in all these 3 directions are equal to 0. So you should identify whether the structure is a two-dimensional structure or a three-dimensional structure, whether it is pin jointed or rigid jointed. Then you can make use of the corresponding equilibrium equations to analyze the unknowns at the support. So now we shall relate to find these unknowns at all these support or these redundant forces with the equilibrium equations, whether it is two-dimensional or three-dimensional, whether it is pin jointed or rigid jointed. Make use of the corresponding equilibrium equations and find the values of the unknown forces. By now you should know the number of unknowns in a fixed end is 3. So it is restrained to move in the vertical direction, it is restrained to move in the horizontal direction, it is restrained to move in the angular direction. So we tell there are 3 forces at this fixed end. So theta is not possible, delta H is not possible, delta V is also not possible. Next, for a pinned end, let me draw like this: pinned end. We draw 2 reactions here telling these 2 are the directions of restraint, one in the vertical direction and the other one in the horizontal direction. So it cannot move in the vertical direction. Delta V is not possible because it has a restraint. Delta H is not possible because it has a restraint in the horizontal direction. There is no resistance in the form of moment in the angular direction. So theta exists at the pinned end. Next, for a roller support, I can draw like this or I can draw like this. Both are roller support. So for a roller support, there is a reaction perpendicular to the base. There is a reaction. So this is the direction of reaction, telling that there is no vertical direction displacement. It has a force in the vertical direction. If the loading is in the upward direction, reaction will be in the downward direction, and the vice versa. There is no restraint in the horizontal direction, so delta H is possible. There is no restraint in the angular direction in the form of moment, so theta is allowed, so rotation is possible. So you should not confuse with this and these values. These are the internal forces or the redundants. These are the possible displacements that can be allowed in these type of support. So here we tell the total number of unknowns in this fixed end is 3. Let me take it as capital R. The total number of restraints in this pinned end is 2. The total number of restraint in this roller end is 1. These are the redundant forces. So here displacement directions, I can name it as degrees of freedom. How far it is free to move. Degrees of freedom. So for a fixed end, there is no possibility of rotation or displacement. Degrees of freedom is 0. For a pinned end, there is a possibility to rotate at this pinned end because there is no restraint in the form of moment in the angular direction. So degree of freedom is 1, that is in the theta direction or rotation direction. Third, for a roller end, there is restraint only in one direction or a force only in one direction. The other 2 directions, that is horizontal direction and angular direction, it is free to rotate and move. So we had 2 directions of displacement. So degrees of freedom is 2. So if you're understanding this concept, then the rest is very easy. Now we go into a simply supported beam. So let me consider a simply supported beam. So here I can write there are two reactions at the hinge end and one reaction at the roller end. So here, as well as here there are three reactions. My capital R for this structure is 3. Okay. Now this structure is a two-dimensional structure. So we know for a two-dimensional structure, sigma V is 0, sigma H is 0 and sigma M is 0 are the three equilibrium equations for any two-dimensional structure. With these we can find the number of whatever other unknowns at the support. So now coming to the problem. So we have equilibrium equations. Let me take it as small r as 3. This is the number of restraints or the redundants, okay, at the support. Small r is the number of static equilibrium equations available. Static equilibrium equations available for a two-dimensional structure. So if I am able to find the unknowns of the given structure with the help of equilibrium equations available, then I tell the structure as a statically determinate structure. The term statically determinate structure is explained now. How? If the number of unknowns in the given structure is equal to the number of static equilibrium equations, then the structure is said to be as a statically determinate structure. Or I can tell if the unknowns in the given structure can be analyzed with the help of equilibrium equations alone. Only these three equations, so equilibrium equations alone. Then I can tell the structure as a statically determinate structure. So you should know what are the equilibrium equations now. So sigma V is 0, sigma H is 0 and sigma M is equal to 0. So we make use of these three equations to find the unknowns at the supports. Same way, let me take one more small beam. Let me take a cantilever beam. So we have discussed already for a fixed end, it has three reactions: vertical, horizontal as well as moment direction. So here the other end is free, it is restrained from any reactions. Only at this support we have reactions. So capital R for this structure is 3. Number of restraints is 3. It is a two-dimensional structure. Number of equilibrium equations available is 3. Small r is 3. So I can calculate these unknowns capital R values with the help of these three equilibrium equations, since r minus r is equal to 0. Or I can form equation like this: r minus r is 0, both are same. If I can find the redundants or the restraints in the given structure with the help of equilibrium equations alone, then I can tell the structure is a statically determinate structure. So all statically determinate structures are stable structures. So you should understand, to determine whether it is a statically determinate structure or not, I can make use of the relation r minus r equal to 0. R minus r equal to 0.